Hello, my name is Yipeng and I am a graduate student in the Department of Material Science and Engineering at the University of Michigan. And in this video, I'm going to talk about how to make an airplane lighter. But first, I want to ask, do you like the idea that the airplane companies offer you to check in 3 bags for free instead of just 1 or even none? Most of us will say yes without any hesitation. I guess we've all come across the situation that we have to spend money on the overweight or on the additional bags for check-in. But this money may be saved if the planes are lighter and are able to carry more baggage. A lighter plane can also carry more passengers, and they will consume less fuel to take off, fly, and land. This is probably the most important thing, as we are aware of the rising prices of the oil and the warnings that the fossil fuels are limited. So we know it's important to make a plane lighter, and the question is, how do we achieve that? It turns out this topic has been an ongoing research since the invention of the plane itself. When the Wright brothers introduced the first ever plane in 1903, their plane was made from wood and metal. In the 1920s, the world started to switch to all metal planes. And up to now, the majority of the planes flying in the sky are mostly composed of metals. Let's take a quick look at what are the metals that people use to build a plane. They use steel, aluminum, magnesium, and titanium. Different planes use different combinations of these metals. At early times, steel is the primary component, while later aluminum replaced the steel and became the major structural material. When it comes to build a lighter plane, it seems easy as we just need to search for lighter metals, but there are only 3 metals are lighter. They are sodium, beryllium, and lithium. Sodium and lithium are soft and dangerous. Beryllium is a rare element and it's difficult to process. So looks like we don't have a metal that could substitute for steel or aluminum. But scientists and engineers are so smart that they developed a new category of materials called composite material. A composite material is a material made from 2 or more constituent materials. In a 2-component system, the major part is called matrix, and the minor part is called reinforcement. This is like a high-rise that made it from concrete and steel. The concrete is the major part, while thousands of steel bars reinforcing the concrete. The best part of the composite materials is they are lighter than conventional materials, but they're also stronger. The reason is both matrix and reinforcing materials are typically lighter than conventional metals, and the reinforcing materials are much stronger than conventional metals, which makes the whole composite stronger than metals. Because their properties are so attractive that the recent planes started to import this new type of material, and the percentage is growing rapidly. For example, the usage of composite in 747 is only 1%, but the usage increased to 11% for the 777, and this number raised to 50% for Boeing's latest model, the 787. Compared with the 777, 787 is 20% lighter. Now you may ask a question that can we further improve the mechanical property of those great composite materials? Can we make them even lighter and stronger? The answer is yes, we can. Studies have proved that this can be achieved if you add a tiny amount of something called nanoparticles into the original composite. The nanoparticles have many different shapes, but the sizes are at least 100 times smaller than the width of your hair. However, the addition of a small amount of nanoparticles into the composite material can induce great improvement in mechanical property. This looks great, but we can continue asking if we could do an even better job. The answer is still yes. This is actually what I've been working on. It turned out if you could distribute your nanoparticles uniformly in a composite, you can push the mechanical property even better. And this is still not the end. Through some manipulation, when you have all of your nanoparticles oriented in one direction, you get a further improvement in mechanical property. So we start from the original composite. We get an improvement in mechanical property when we add some small amount of nanoparticles. We get a further improvement when we have nanoparticles distributed uniformly. Then it gets more improvement when we purposely make them oriented in one direction. These intentions of strengthening composite materials are important as we can build a plane with even more weight reduction. And that goes back to a lighter plane will consume less fuel and save a large amount of money. And one day when you arrive at the airport and about to check in your baggage, your airline receptionist may tell you that you can have 3 bags to check in for free. And how great is that? Thanks for watching.